In this lesson, we're going to learn about scientific notation and how to write large or very small numbers in scientific notation, or how to convert from scientific notation to standard form. All right, so the first thing that we're going to look at is that if we're writing numbers that are large numbers, like here, we're going to use 10 raised to a positive exponent. If we have numbers that are decimals or numbers that are less than 1, then we're going to use a negative exponent. In general, numbers that are written in scientific notation are always written of the form of one number that's between 1 and 9, then the decimal point right here, and then all the rest of the numbers that are in that number until you either reach the end of the number or you have nothing left but zeros at the end of the number. Right? There can be zeros in here, but as long as there are other non-zero numbers after that, you would keep going and until there's nothing but zeros left. And then your exponent here is either going to be a positive or negative number that tells you how many times that you've moved that decimal point either right or left. So pause this video and copy this information into your notes. As I had just said a minute ago, if the exponent is a positive number, it's going to be a large number that's bigger than 1. In what I'm doing here is I'm going from scientific notation to standard form. All right, so we have 5.62. You notice it's written in that standard form. We have one number and the decimal point, and then the rest of the numbers times 10 to the 8th, which means that we're going to have moved this decimal point 8 times. All right, and we could put put commas in there. Sometimes commas can be a little bit confusing, so oftentimes I don't worry about the commas. If an exponent is a negative number, it's going to be a decimal number less than 0. So 9.24 times 10 to the negative 8 is going to be a decimal number with a bunch of zeros in front. Up here with the positive 8, you had a bunch of zeros after the 5.62. Pause the video and copy this information into your notes. The exponent tells us how many times to move the decimal point either to the right or to the left. If we're going from scientific notation to standard notation like we just did in the previous slide, a positive exponent moves the decimal point to the right. So positive moves the decimal point to the right. And a negative exponent moves the decimal point to the left. If you're going from standard notation or a whole number to, or not necessarily a whole number, if you're going from a non-scientific number to a number that's in scientific notation, the opposite is true. If you move the decimal point from the end of the number to the beginning, the number of times it is moved until you have one non-zero number in front of the decimal point, the exponent is going to be positive. If you begin with a decimal number, obviously the key word here is decimal number, you know that if you have a decimal, we've already established this, that if you have a decimal number, the exponent is going to be a negative number. So the number will be the number of times it's moved until you have one non-zero number for the decimal point. And once again, you make it a negative. Remember, if it's a whole number or a big number, the exponent is going to be positive. If it's a decimal number, the exponent is going to be negative. pause the video and copy this information into your notes. All right, so we're going to do several problems where we're going to practice that. Okay, so write each number in standard notation. So we're going from scientific notation here to standard notation. So you notice that we have 6.2 times 10 to the 7. So we're going to start off with 6.2, and because the 7 is a positive number, we know that we're going to have a large number. We're going to have a large number. We're going to move to the right. Okay, we're going to move to the right 7 times. So we're going to go 1, 2, 3, 4, 5, 6, 7. So our decimal point is going to end up all the way down here, and we have to put in zeros as our place value holders. Okay, so we put in a 0 everywhere that there is a dip. Okay, so this would be, and my decimal point obviously got higher than what it normally would, but 6, 2, then we have 1, 2, 3, 4, 5, 6, 6, 0, 1, 2, 3, 4, 5, 6. You do not have to put that decimal point at the end. You normally, if you have a whole number, you don't put the decimal point at the end. You count back 3, put a comma, count back 3 more, put a comma, and it would be 62 million. All right. The second example, 1.47 times 10 to the 5. Once again, the 5 is a positive, which means that we're going to move it to the right because we're going to have a large number. So 1.47, we're going to move it 5 times. 1, 2, 3, 4, 5. Decimal point's going to end up over here. So we have to add the zeros, and we end up with 147,000. Don't worry about, you don't put the decimal point at the end of a whole number. Come over 3 and put a comma, so it's 147,000. Our next example is 1.33 times 10 to the negative 7. Okay, remember, if it's a negative exponent, then we're going to end up with a decimal. So I'm going to start off here to the right a little bit further. So 1.33, and it's a negative 7. So that means we move left 7. 1, 2, 3, 4, 5, 6, and 7. And we fill in with zeros. So our answer is, and now oftentimes what I'll do is I will put a 0 in the front here just to show that it's a decimal. So 0 point, this 0 up here, that does not count as far as in the places we move. So 0 point, let's see, how many zeros do we have? 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6. 1, 3, 3. And remember, if we have decimal points, we do not put decimal numbers, we do not put commas in there. All right. The next one, 3.24 times 10 to the negative 2. It's a negative exponent, so we know we're going to end up with a decimal, which means we're going to move to the left. I'm going to start off to the right a little bit more to give myself a little bit of room. 3.24. I move it left 2 times. 1, 2. So this only has the 1 0. So I rewrite that as 0.0324. Our next example is going from standard notation to scientific notation. So remember, if we have a whole number, then know that the decimal point is at the end. Okay, so it'd be right here. All right. So, and we want it to end up right here where that comma is. Okay, but it's not always with the comma. It's just that that's the way it happened to work out this time. So we're going to want it to be 6.98 and then we have nothing but zeros left, so we stop there, times 10 to the, now how many times do we have to move? Well, we have to move it 1, 2, 3, 4, 5, 6. And it's going to be a positive 6 because we end up with a large, we started off with a large number, okay? Remember, if it's a large number, a whole number, it's going to be a positive exponent. Same thing with this one down here. We start off here, but we want to end up right here. All right, so it's going to be 7.045. Remember, this has a 0 in it, but that's not, there's other numbers after the 0. Okay, but there's no more numbers after the 5 other than zeros. So we 0.045 times 10 to the, and once again we count 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 10 to the 9. The last set of numbers in scientific notation are writing decimal numbers. Okay, so we obviously start off right here. We want to end up between the 5 and the 7 because we want to have one number in front of the decimal point. Only one. All right, so we don't move it to the end. We only move it to until there's only one number in front of the decimal point. So it would be 5.7 times 10 to the count 1, 2, 3, 4, 5. And because it's a decimal, it's going to be a negative number, so it would be 5.7 times 10 to the negative 5. And here, in this last example, our decimal point is going to end up here right after the 3. All right, there's no other, 3 is the only non-zero number in this decimal. So simply, it's going to be 3 times 10 to the, count here, 1, 2, 3, 4, 5, 6, 7. So it's a decimal, so it'd be to the negative 7. All right, so make sure that you understand the notes that you've copied down. If you don't understand them, get in touch with me or ask me questions and take a look at your classwork that I've assigned. See you later.